When we imagine the day humanity finally leaves the solar system, most people picture a sudden launch, a single giant ship firing its engines and disappearing into the darkness between the stars. But the reality will be nothing like that. Leaving the solar system isn't an event. It's a process, a slow transformation of our species as we learn to master energy, resources, and life beyond Earth. For humanity to even consider such a journey, the first step is understanding the scale of the challenge. The solar system is vast, measured not in millions of kilometers, but billions. And beyond it lies a gulf so enormous that traditional rockets are meaningless. The fastest spacecraft ever launched would take tens of thousands of years to reach the nearest star, which means before we take a single step outward, we must reinvent how we travel. The earliest stages of this journey begin not with starships, but with infrastructure, the foundations of a civilization that can survive beyond Earth. Over the next few centuries, we will learn how to build large-scale vehicles that operate efficiently in space, powered not by chemical engines, but by nuclear and fusion systems capable of sustained, high-energy thrust. These vessels won't take us to another star, but they will teach us how to survive away from Earth, how to transport materials, and how to construct habitats far from home. Mining the solar system becomes a necessity. Earth simply doesn't have the materials required to build a starship capable of a centuries-long voyage. Asteroids, rich in metals, carbon, ice, and minerals, become the supply lines of early interplanetary industry. Robotic miners, fusion-powered tugboats, and orbital foundries will gather and refine resources, building the massive structures humanity will one day depend on. Energy, too, becomes a defining factor. To push a ship even a few percent of the speed of light requires unimaginable power. This leads us toward orbital solar farms, fusion reactors, and giant reflector arrays near Mercury, where sunlight is intense enough to generate staggering amounts of energy. These megastructures form the backbone of early interstellar preparation, transforming raw solar power into propulsion for exploration. This phase may last centuries, but it is essential. Before we can leave the solar system, we must become a civilization that lives comfortably inside it, one that moves between planets as easily as we move between cities today, one that mines asteroids the way we mine quarries, and one that can build structures larger than anything ever created on Earth. As humanity expands outward through the solar system, something fundamental begins to change. We stop thinking of space as an empty void and start seeing it as a landscape, a place with resources, routes, hazards, and opportunities. Cities on Mars become staging grounds, asteroid stations turn into industrial hubs, and vast orbital habitats grow into centers of science and engineering. We develop expertise in living far from Earth, relying on artificial ecosystems, closed-loop recycling, and fusion-powered agriculture. These environments teach us what a future starship will require: stability, redundancy, and a way for thousands of people to survive for generations without ever touching soil or seeing an open sky. The solar system becomes a training ground, preparing us for the immense difficulties of living on a ship that must cross light years of emptiness. But before any interstellar mission, humanity must master the art of building megastructures. Starships capable of reaching even a fraction of the speed of light cannot be constructed on Earth. They are too large, too delicate, and too dangerous to assemble within a gravity well. Instead, they will be built in orbit around Mercury, where solar energy is abundant and where automated factories operate without interruption. These construction yards produce components measured not in meters, but in kilometers. Hull sections are forged from asteroid metals, shield plates assembled from layered ice, mined from distant moons, and enormous fusion chambers built piece by piece by autonomous drones. It is here that humanity begins assembling the first true interstellar arc, a rotating megastructure designed to house thousands of people in artificial gravity for decades. To protect its passengers, the ship must have shielding strong enough to withstand high-speed dust grains that could strike with the force of explosives. Scientists envision a layered protective system, a thick ice barrier at the front, constantly replenished, a magnetic field to deflect charged particles, and a plasma shield that vaporizes incoming micro-debris. This trio of defenses transforms the starship's bow into a glowing, reinforced rampart built to survive the violent environment between the stars. But even with shielding, propulsion is the heart of the mission. Fusion engines, likely fueled by helium-3, mined from the atmospheres of Uranus and Neptune, produce incredible thrust while remaining efficient over long periods. Gathering this fuel becomes an industry of its own, with scoop ships diving into gas giant atmospheres to collect precious particles. Helium-3 gives humanity the power to accelerate to several percent of the speed of light, enough to make interstellar travel feasible within a human lifetime. Yet, even at these speeds, the journey requires patience. Decades of acceleration, followed by decades of coasting, and finally years of deceleration upon arrival at another star. Humanity prepares not for a voyage, but for a relocation. The moment humanity gathers enough energy, resources, and confidence to send its first interstellar vessel outward is not marked by fireworks or celebration. It's quieter, more contemplative. Engineers, scientists, and ordinary people watching the launch will understand that what they're seeing is not a mission, but a migration. The first deliberate step toward a future where humanity is no longer bound to a single star. Acceleration will be slow at first, barely noticeable. The starship will glide away from the sun, engines glowing faintly as the ship gathers momentum over months and years. From the outside, it will seem serene, almost gentle. But inside, thousands of people will feel the subtle shift of simulated gravity as the vessel rotates, creating a sense of normalcy. Children will take their first steps in hallways that curve toward the sky. Families will live in fields lit by artificial suns. Scientists will monitor the heart of the fusion reactor, ensuring that humanity's most ambitious machine continues its steady push toward the stars. As the ship accelerates to several percent of the speed of light, the familiar constellations begin to distort. Stars stretch slightly, the background darkens, and the sun shrinks into a brighter than usual point behind the ship. This is the first time in history that human eyes witness the solar system fading into the blackness of interstellar space. For many on board, this will be a moment of awe, and a moment of realization that there is no going back. The long cruise phase begins next. For decades, life aboard the starship will follow predictable rhythms. Agriculture cycles maintain food supplies, recycling systems handle air and water, and families continue to grow. Generations overlap. People who were children at launch grow into adults, taking responsibility for maintaining the vessel and preparing for arrival. In many ways, the ship becomes not a vehicle, but a society. Complete, self-contained, and shaped by the purpose of reaching another star. During this long period, the ship will pass through regions of interstellar dust and radiation. The shielding at the bow absorbs countless impacts, tiny grains of dust traveling so fast they could punch through metal if not for the layers of ice, plasma, and magnetic fields. Engineers monitor these collisions constantly, replacing damaged segments and recalibrating shields as needed. Radiation storms from distant supernovae occasionally sweep through space, forcing the crew to shelter in the vessel's heavily protected inner chambers. Yet the vastness of space is not empty. As decades pass, the ship's sensors detect traces of interstellar gas, faint streams of hydrogen, and distant objects drifting silently through the void. Some are ancient comets, others are chunks of rock that never belonged to any star. These moments remind the crew that the universe is not a vacuum, but a living landscape shaped by billions of years of cosmic evolution. Eventually, after a lifetime for some and the entire history of the voyage for others, the ship approaches the target star system, likely Alpha Centauri. The crew begins preparations months before arrival, slowing the ship, rotating habitats to adjust gravity, deploying autonomous probes to analyze planets and moons. As the ship decelerates, the golden glow of Alpha Centauri A grows brighter, accompanied by the cooler orange light of Alpha Centauri B. For many on board, this is the first time in their lives they've seen new stars up close. Probes descend toward promising worlds, scanning atmospheres, analyzing radiation levels, searching for environments where humans might settle. Some planets may be barren, others icy, others scorched. But even if no Earth-like world exists, the system offers countless resources. Moons rich in ice, asteroids filled with metals, stable orbits where rotating habitats can be built. Humanity has not come to conquer a paradise. It has come to build a future from raw materials and determination. Once the landing sites are chosen, the first habitats are constructed: radiation-protected domes, underground chambers, and inflatable structures designed to withstand alien conditions. Solar collectors stretch across rocky plains, water is extracted from ice deposits, and early settlers begin transforming the raw landscape into a home. For the first time, humans stand on solid ground under another star, not as explorers, but as founders. This moment marks a turning point in humanity's story. No longer confined to the world where our species evolved, we have become something new, a civilization capable of surviving cosmic distances and reshaping entire star systems. And as decades turn into centuries, this first settlement becomes a launch point for further expansion. New ships are built locally, new expeditions depart toward nearby stars, and humanity begins spreading like a slow, steady wave across the galaxy. The day humanity leaves the solar system is not the end of a journey. It's the beginning of millions of future stories. Stories of new worlds, new cultures, new branches of our species adapting to environments we can barely imagine. And every step we take outward is powered by the same idea, that survival is not given to us by the universe, but built by our own hands, one star at a time.